Hello and welcome to the Shields UP security webinar from Microchip. This is a webinar where we bring all of our experts together to deliver to you all the latest information about our embedded security products. And today I'm going to focus on the Trust platform for the CryptoAuthentication family. I am Xavier Bignalet and I'm the product manager for the secure product group here at Microchip. So if we start this presentation, I want to give you a snapshot of embedded security. So we'll start with the hardware root of trust, which is really composed of a secure boot and the identity of the system that represents the private key for connected system. If you move up to the next layer, we can talk about counterfeit protections. That's basically when companies are trying to protect counterfeit from disposable goods and protect from copies of accessories. Moving up the stacks, we talk about IP protection. It's really the IP that lives in your code, your RTL code for an FPGA, the firmware code for microcontroller, the software for Linux environments. Then upper stack, we talk about secure updates. Obviously, once you have a new piece of code to replace in your embedded system, you want to push it through a secure update mechanism that can be through a connected system or not a connected system, and think about the USB key as a storage to bring the code into the new system. Then upper stack again, we talk about the secure connectivity. Obviously, as you want to connect to something, you want to make sure the encryption is and the whole communication is correctly secure, using the right practices there. And finally, the last layer, and that's where we draw the line, is the application layer security. It's how the system handles elevation of privilege, or in other words, access rights to the embedded systems. Above that, it's the world of software as services for embedded system or for cloud services, and Microchip does not play in that area. But we do partner with many different companies that offer different value proposition to enhance your systems. Really, the presentation about today is going to focus on the secure elements products of Microchip portfolios. One thing we're going to start mentioning is the notion that keys are triggering algorithm. In other words, the secret, which are the keys, are going to trigger the math, which are really the algorithm. I want you to keep that in mind for the whole presentation. Then the second statement we're making is security is all about the key. Yeah, because the key triggers the algorithm. So what does it mean? It means that if you own the key, you can own the transaction, and the transaction of your system can be impersonated. And now you have a rogue individual that controls your system. Another thing we want to illustrate in that slide is what a private key looks like. And it's just a suite of numbers, of digital numbers. That's all it is. But those numbers are extremely important. So we want to protect them. Unfortunately, today weaknesses there are multiple of them. One of them is security by design. There's not a lot of knowledge in the industry, in the embedded industry, to correctly handle embedded security practices. So because it's hard to implement, there are shortcuts being made during a design that creates backdoors. Due to the lack of education, the concept of chain of trust is often incorrectly implemented or incorrectly protected. The notions of keys and certificates and how you handle them from birth to full production is there are so many challenges that can be that can create gaps, and one of them would be the manufacturing, which is my last point here. Before I get to the manufacturing aspect, let's talk about the backdoors that are opened due to bugs in software and codes. Those bugs are sadly normal, but they do exist and need to be considered as vulnerability to a key. And that if that bug exposed the key, well, there you go. That's the backdoor to a system. And finally, like I said, the manufacturing can't be trusted, should not be trusted. So how do you handle your key during manufacturing? If you do everything you can to protect the device, we'll look at surface of attack before they get into the device, and that is the manufacturing. So there are problem of scales. In security, there is a notion of customization. As soon as you touch a key, that key is unique, and unique for each device, for each product that are exposed to cryptography. So because that key is unique, you have a customization challenge. So how do you supply those keys in a fragmented global marketplace? So that's where the notion of personalization comes in. And this is how it looks like. You start to identify a use case, define transaction diagram, you use complex tools, and right away you need experts' knowledge. The experts are not always there, and they are scarce in the embedded industry. And then you have to configure the authentication, the security models of the use cases you think are the right one to address. Then once you're happy with your prototyping and your system is working, you need to move into the key ceremony to trigger the provisioning service. And that's when we exchange, secrets are being exchanged between a customer and a manufacturing site. And then the manufacturing plants have to be equipped with hardware secure modules. So where do you buy them from, how much you pay for the software, and now you need a team of software, highly skilled software engineers to understand how to handle the software that's running on the HSM. And then at the end of the day, once your part gets out of the supply chain, you have a custom part number. And that is one of the core challenges in the security industry that we want to address. Today, generally, to get an embedded security device that's provisioned, orders have to be greater than 100,000, if not 150,000 units. But there's an entire marketplace that is composed of small size, mid size, and large size customers. So how do you ship a sensitive material, which is the key, in a fragmented marketplace through a complex distribution model? Well, the goal is to reduce the exposure to third party. And if you look at my diagram here where the keys are, I mean, they could be touched anywhere in a regular supply chain process, from the semiconductor manufacturer to the distributors to the contract manufacturer, the OEM, the product, and the end user could be my own parents with their connected thermostat in their living room. And how the keys are exposed there, quite a lot. There's a lot of surface of attack there at each of the steps. So we need improvements, and the improvement that we need are improving the user onboarding, reducing the friction due to the personalization, and make sure the key storage is available to the mass. So that's why Microchip has launched the Trust platform for the crypto authentication family. What is it? What is it that we're launching? So it's a combination of multiple things. It's a secure provisioning service. So we make our secure factories provisioning service available to the mass market with a family of secure devices. We optimized our supply chain channels to automate the process of providing provision device, and we'll illustrate what it means in a few minutes. Everything comes with package code example and a suite of tools. So what we're releasing is all of it, and for any project size. Let's start with the provisioning service. How does it look like? So it's a 3-tier provisioning service that is composed of the Trust&GO, the TrustFLEX, and the TrustCUSTOM service. So with the Trust&GO, devices are coming pre-configured and pre-provisioned. They're pre-configured to do device-to-cloud authentication, that's it, for 2 types of networks, TLS-based network and LoRa-based network. The minimum orderable quantity is 10 units, and that includes provisioning, right? And we'll give the details in a few minutes. The TrustFLEX comes pre-configured with more use cases than just device to cloud, cloud to device use case. It is pre-provisioned, so it is pre-provisioned with the same generic certificates that are in the Trust&GO. But Trust&GO lock those certificates and keys. So Trust&GO, you can look at it. It's a brick. It's a black box you get. TrustFLEX, even if those default generic certificates are there, they can be changed by your own custom PKI. And here the minimum orderable quantity, including provisioning, is 2,000 units. And finally, the TrustCUSTOM service is a device that is not pre-configured and is not pre-provisioned. It's a device that's fully customizable. The MOQ here is 4,000 units, again, including the provisioning service. So moving on to the device and what is the device supported today? It's the ATECC608. We started with the device. It's one of our key products. And what it is inside the device, it's a tamper hard run secure element, secure key storage with side channel attack protections. And really in the bulk of this device, you have a high quality random number generator, hardware accelerators such as ECP256, SHA-256, AES-128. You'll have a 16 slot secure EEPROM, unique serial number, and 2 monolithic counters. And of course, the device is equipped with IOs. Here for the Trust platform, we've been focusing first on the I2C IO. So how do we make sure the device is robust? We work with third-party labs, and one of the latest lab test reports we got granted the device what we call a JIL high rating. So what the JIL high rating, how a JIL high rating is, we provide those third-party labs the file that they require from us to test our device, and they try to extract the private key. They are given 3 months of effort to do that, and if they manage to extract the keys, you get a number between 1 and 31. Having a number is not necessarily good because the key got out based on the test that they are practicing. If you get a JIL high, which is the highest rating, in that amount of time they did not manage to find a solution to extract the key. Would they have longer? Probably they would have found a solution. Who knows? The device comes also with a library. It's called CryptoAuthLib library. It's a library that lives in the microcontroller and that keeps the system, the secure element, completely agnostic of the core that's being used. It could be a microcontroller, microprocessors. CryptoAuthLib has all the low-level API to talk over. So in that case, I2C between the microcontroller and the secure element. Here you have the link. The library is open source. Please participate on our GitHub forum and ask your questions right there. Next point is the tools and examples. So here we have a very important tools that will be new to users. It's the Trust Platform Design Suite. The idea is to create an easier onboarding. So this tool helps you through all your prototyping all the way up when you're going to start getting into production. And I'll explain what it is in a minute. So first you need to define what you want to do. You define your use case or your use cases when there are multiple of them. So the tool, what we've done in that tool, for the past few years, we've identified the most common use cases used in the industry, and we've basically implemented there. So the only thing you have to do so far is just click on the use case you're interested in. In the little picture here, you will see secure boot IP protection and TLS use case. Once you've selected that, what it'll do, it'll point you to Python executable tutorial. Those will be running on that Jupyter notebook. So it's a software tools that run Python code. And those examples allows you to test from your laptop to the secure element that will be loaded on a USB type of board. We'll show the hardware in the next slide. And you can test your challenge and responses depending on the use cases you've been selecting in step 1. So once you prove your secure element is correctly configured and provisioned using the prototype credentials the tool also offer, that means it gives you a really good confidence level. Your secure element is pretty much good to go. And then you move to the development phase. Development phase, you want to move out of the laptop and get the equivalent code in C code, right? So we also provide the C files as projects for different IDEs. The codes are basically reflecting what we've done in Python, and again, you move from the laptop testing to the microcontroller. The last step here that you'll achieve with the tool is completing the secret exchange file. So it's an XML file that will need to be provided in encrypted fashion to Microchip. So we have an encryption utility to handle the encryption of the file. And we provide a template, especially for TrustFLEX. That's where it's valuable. Trust&GO doesn't need to be configured. It's already done and provisioned, so there's nothing to do with it. With TrustFLEX, we have the map of the 16 slots of the device that are already pre-configured. So the only thing you have to do when you get into the tool is fill the fields that are asking for, the search, the public keys or the asymmetric keys, and however the use cases you've selected in step 1 will be reflected in step 4, and those are the secrets and information you have to fill in the file. I'll show you the rest of the process for TrustFLEX in a minute. Before, I want to talk about the hardware solutions that goes along with that software tool. So the main board will be your Trust Platform USB kit. That's the USB kit that I was mentioning. We have a USB port and you have all the variances of Trust&GO, TrustFLEX, and TrustCUSTOM here. If those 3 devices alone are not enough and you manage to mistakenly lock them or whatever, you can use this add-on board, which also has multi-variances or multi-options of Trust&GO, TrustFLEX, and TrustCUSTOM. Here you see 8 devices. If that's still not enough, you have a socketed option you can buy from microe.com that you snap on top of the Trust Platform USB kit. And if you're more comfortable to work with the Explain Pro form factor, we also have a socketed version for that port. We also provide complete stack solutions to help you to fast track your development. So when we provide a solution, you'll have code for the microcontroller, like we explained, that operates or Wi-Fi. That would be mostly the Wing 1500 that's being used with the ATECC608 in the Trust Platform versions that you've selected. But we also, in those files, you'll have all the necessary code to do full connection to Amazon, Google, Microsoft, LoRa network that includes Actility and the Things industry. We also partner with Wolf SSL. We've worked with ARM to develop an embed TLS solutions, and Arduino is using also a Trust Platform solution in some of their platforms. So at the end of the day, what you'll have is a wiki user manual on GitHub, turnkey code examples hosted on GitHub, and complete hardware solution, again, including microcontroller, connectivity, secure element, and all the code examples that connect you to the most popular cloud platforms. Moving on to the supply chain value. So the supply chain, really, we need to talk about the Trust&GO first and see what's inside that device. So like I said at the beginning, it addressed device to cloud authentication for both IP-based cloud TLS and LoRa, that type of network. So for IP-based TLS network, if we look at the 3 main platforms, Amazon, Google, and Microsoft. So Amazon has something called multi-account registration. Google has something called JSON Web Token Authentication. And Microsoft has the concept of certificate tampering. So what does that all mean? It allows you to authenticate a device with only the device certificate, or in other words, the public key in some cases, if we simplify it. There is no verification of that device level certificate by a signer certificate or an intermediate certificate. That is not in place with those architecture, which makes the architecture much simpler and cheaper to implement. And we'll see why in a minute. For LoRa, basically the secure element comes with application and network keys pre-provisioned with rekeying features also implemented in the state machine of the secure element. So the value for Trust&GO, it's basically much easier to use because when you get it, you get the parts. There's nothing to do on the parts. It already has the credentials, and you save a lot of cost because you don't need to hire a third-party PKI management service and buy a full chain of certificate from a certificate authority that could be extremely costly. It's all baked into the cost of the device. Obviously, we keep the connectivity agnostic of whatever the network is, and we offer all of that with a very low MOQ to make the technology available to the entire mass market. It does simplify the logistic a lot, as you can buy a smaller chunk of devices as your project grows across the years. You never know really exactly how much you're gonna buy, and if you're stuck with MOQs of hundreds of thousands of units, it becomes a bit more challenging to manage inventory there. And at the end of the day, it all provides a much shorter time to market, and again, a much more cost optimized cost structure. Trust and Go and the ordering process. So how does it look like? So you're the customer. If you want a Trust and Go part, you order it from Microchip or one of our distribution partners, and you get a device and a manifest. The manifest is basically a digital file that you'll download from the e-commerce store of choice where you buy the part, and Microchip ships the provisioned Trust&GO ATECC608A to the customers or to the distributor that will ship to the customer after. The manifest file is uploaded by the customers into the cloud platform of choice, and what's inside that manifest is basically the certificates and public keys and serial numbers of the devices of the purchase. If there are two orders being placed, there will be two manifests, including the amounts of devices per orders. And at the end, what you complete is a secure, trusted, and managed authentication between your cloud and the device, without having exposed the private key inside that supply chain process at any point of time. TrustFLEX is you can think about Trust and Go with more use cases. So if there are two questions to ask. Are you comfortable with the generic certificate that Trust and Go offer? Yes or no? If no, you want to look into TrustFLEX, or do you want more than just the cloud to device authentication? And so now comes TrustFLEX that you can use to implement, custom certificate authentication. So you can override the generic certificates that are already there in the device. And you can also do JSON Web Token authentication. You can do Secure Boot Verification Assist, OTA verification, firmware IP verification protection. So all of those Secure Boot, OTA, and firmware IP protections are really verification of a signature or digest coming from a signed code. That's what it comes down to, really. It depends on when you do it. You could do message encryption, key rotation, IO protection key. So IO protection key is basically a feature that pairs the microcontroller with a secure element in a unique fashion using a shared key mechanism. Or you can also do host accessory authentication to have a controlled accessory strategy for your system. So all those use cases are baked into the TrustFLEX. So what's inside the TrustFLEX? What are really the value? Again, the low MOQ make our technology available to the entire mass market. Back to my comments on managing inventories and making the value of secure key storage available to the entire marketplace, because the IoT marketplace is extremely fragmented, right? And has a lot of projects running only a few thousands of devices. So now the tech is available for those type of application. We've predefined the device with the most commonly used use cases in the industry. So we've done the job for you to fast track your development. And not only that, but we've left the flexibility to accommodate your own secret inside that device, even if it's pre-configured. And at the end of the day, this Trust Platform Design Suite that I've been showing just a minute ago simplify the engagement model. So through all the prototype phase to the development to when you start your secret exchange, everything is baked in that tool to turn. Literally, that's how we turn months of development into minutes. And we've tested it with customers already. We're really turning months into minutes. So the TrustFLEX flow, looks like that. So I'm the customer. I want to order a part, but the first thing I need to do is work with the design suite, the Trust Platform Design Suite, select my use cases, do my prototyping, and once I'm done, I'm ready to generate that XML file. Once I've generated the XML file with the Trust Platform Design Suite, I use the encryption utility that's also part of the downloaded package, the Trust Platform package. And I'm going to encrypt the file. What you're going to do, you're really going to go to microchip.com/support and open a ticket. In that ticket, you're going to say, hey, I want my TrustFLEX part to be provisioned, and you're going to upload that encrypted file in your ticket supports on microchip.com/support. What we do, we create a manifest that reflects the provision secure elements. Distributors are equipped and enabled to use that flow. We ship the provision devices, and the manifest is downloaded by the customer into its account. And the manifest is also uploaded by the customer into the cloud provider of choice. So at the end of the day, you're going to have a solution here that's completely agnostic of the certificate authority of the cloud, and you leverage the most common authentication use cases. And we create a secure, trusted, managed authentication, again, just like we did with Trust&GO, with a slightly different model. TrustCUSTOM is basically a fully customizable device that has a low MOQ, a low minimum orderable quantity of 4,000 units, including provisioning. The device really can become anything. So the benefit here is the customization capability of the device is accessible to the low volumes projects. We simplify the onboarding with a new tool. So that tool will only be available under NDA because it's a custom work, right? For TrustFLEX and TrustCUSTOM, there's absolutely no need for NDA. And then obviously the keys are still protected in that JIL rated secure key storage. The TrustCUSTOM flow looks like that, where you start to identify use cases, you define your transaction diagram, you will define the configuration of the secure element, and then what the customer will own is to prototype the code of because we don't know what we don't know. We can't predict what the application will be in a custom use case. So the customer owns completely development of the firmware, while in TrustFLEX we provide solid code-based examples. Then we go back to triggering the provisioning process with the secret exchange, and then Microchip provides validation article. What they are a few devices that we ship to you, the customer, that you can test the actual secure element is correctly provisioned coming from different manufacturing sites, and the configuration and the provisioning are consistent wherever the site is. And then finally, you go to production. Now we're going to look at what the customer journey looks like. We'll start with the Trust&GO and ask those three questions. Are you okay using generic certificates for thumbprint authentication? Is the cloud infrastructures that you're leveraging support generic certificate authentication? Meaning the authentication, again, is only relying on the device level certificate. Are you okay if you implement only cloud authentication use case and nothing else? If the answer is yes, we'll move you through the Trust&GO concept, which is get the part, get the hardware, start prototyping with the use case code example we're providing, and we'll move you to production because you just have to buy the parts there. If no to any of the questions was present, we'll move you to the TrustFLEX. TrustFLEX, we ask you one question. Are you okay with the predefined use cases? If the answer is yes, we move you through the TrustFLEX flow, which is select your use cases, use the design platform, the Trust platform design suite, implement the codes, and go to production after the secret exchange. If no was the answer to the question, we move you to TrustCUSTOM. And TrustCUSTOM, it's basically the process that I've defined a few slides ago, which is detail your use case definitions, go through the lab evaluation, generate the secret exchange, prototype, low volume production, and move to high volume production as things go through. Here's a snapshot of the family of devices, which is really representing all the TLS-based Trust&GO, TrustFLEX, or the LoRa-based devices for, again, Trust&GO and TrustFLEX. You also have the TrustCUSTOM part number. It depends on different type of packages and minimum orderable quantity. And as a takeaway, really what you want to remember is we've been trying to make everybody's life easier, making the technology available to the entire marketplace, no matter the project size, by providing easier onboarding with predefined use cases. We offer simple to use tool sets with the Trust Platform Design Suite. We benefit from the power of e-commerce stores to distribute those manifest files. That includes the public credentials. We keep this entire process fitted for the mass market and offer low MOQ, including provisioning services, leveraging Microchip secure factories. And finally, all of that will continue to be agnostic of whatever the architecture is, whether it's the cloud, whether it's the PKI, the controller, or the connectivity itself. I want to thank you for your time and attention. and hope to see you in the next Shields Up webinar. Goodbye.